Okay, so on to chapter 1 now that we've finished the appendices. And so we will start with linear equations and inequalities, which is section 1.1. Linear equations you've seen before. These are pretty straightforward. So something like 7x minus 3 equals 0. You had to solve these when you were solving factors of quadratic equations for roots. You get equations like this. So 7x equals 3. You add a 3 to both sides to get that 3 there. X equals 3 over 7. You get that by dividing both sides by 7. And so there, we've solved for x, right? That's the goal of solving equations, to get x all by itself. We can graph this. This is yield x-axis. Little arrows at both ends. You put a little circle and you say, well, that's 3/7. That's my solution. Okay, so inequalities are pretty straightforward. You've got an equation, linear equations are pretty straightforward. You've got an equation that's got an x to the first power and some numbers. Just get the x all by itself. Linear inequalities are very similar with the same types of operations to solve them, except for one small twist that you have to keep in mind, and we'll see an example of that in a minute or two. So we'll start with, say, 3x plus 2 to be greater than 7. So what are we looking for here? We're looking for all numbers that if I plug them into this left-hand side, 3 times x plus 2, I get something out that's bigger than 7. There are lots of possible numbers. How do we find out what they all are? Well, same procedure. Subtract a 2 from both sides. That'll give me a 3x plus 5. And then divide both sides by 3 to get rid of this 3 over here. And that gives me x greater than 5/3. And we can graph that. There's my x-axis. Here's, oops, I don't want to fold in line. 5/3. And all the numbers bigger than 5/3. I leave an empty circle here because I'm not including 5/3, right? I need x, any number strictly bigger than 5/3. Okay, so what is this picture here of this line with the circle and this shaded part scribbled in there? What does that actually mean? Well, take a number from this side. Any number. Say 6. Right? 6 is definitely bigger than 5/3. What's 3 times 6 plus 2? Well, 3 times 6 is 18, plus 2, that's 20. Is that bigger than 7? Definitely. Right? So any number that's bigger than 5/3, if I plug it in for x here, then take 3 times it and add 2, I'll get something bigger than 7. If I take any number over here, on the other hand, on the left side, that's not shaded in, say, well, 0. 3 times 0 plus 2 equals 2. Bigger than 7? False. Right? I'll put a little question mark. So, take a number from this side, plug it in for x, you get something that doesn't work. You get, in this case, if x equals 0, you get 2, and that's not bigger than 7. So this side are numbers that don't work in this inequality. This side are the numbers that do work. 5/3 doesn't, because if you put in 5/3, you get exactly 7 on the left side, and we're actually looking for numbers that give you something strictly bigger than 7. So this is a linear inequality. Actually solving them isn't too hard. There's lots of different notations for this. I like x greater than 5/3 as a solution. You'll also see in interval notation, it means any number from 5/3 to infinity is a good number to plug into this. So what about double inequalities? Well, it's the same thing, except now you have 3 sides. So minus 1 less than 4x plus 3 less than or equal to 15, for example. Now I've got 2 inequalities, but you solve it the same way. Subtract a 3 from all 3 sides. So I actually want to subtract a 3 from the left side, from the middle side, and from the right side. Minus 1 minus 3, that's a minus 4. Plus 3 minus 3, well, that's 0. And then 15 minus 3 is 12. And the goal here, again, as it is in solving all equations, is get the x all by itself. And now we can divide through by 4, all 3 sides. Minus 4 divided by 4 is minus 1. 4x divided by 4, that's just an x. And 12 divided by 4 is 3. So, there we've got it. And again, we can draw a little x-axis. Minus 1, 3. The 3 should be filled in. because we're including 3, right? Less than or equals to 3. 3 is a good number, so we fill it in. Minus 1 is not a good number, it's a bad number, and so we leave that empty. And all the numbers in between. So what does this mean? Well, again, if I take any number in here, any number from in here, that actually works, right? If you plug in, take x equals 0, for example, and plug it in, 4 times 0 is 0 plus 3. That'll give you 3 in the middle, and 3 is between minus 1 and 15. Numbers from these two places don't work. Right? If I take, say, 10 and plug it in for x, I get 43, and that's bigger than 15, so it doesn't work. If I take, say, minus 10, then I'll get minus 40 plus 3 is minus 37, and that's less than minus 1, so that doesn't work. Why we're interested in this sort of thing is, you know, this could be profit or something, and you have certain bounds on it. You can only, well, cost maybe, and you can only spend that much, and you can borrow that much. So, and I did say that there was one last, one little trick to dealing with this that inequalities have that are a little bit different from equalities. So consider this, 4x minus 4x plus 5 is greater than or equal to 7. So we'll subtract a 5 from both sides. So you get minus 4x is greater than 7 minus 5 is 2. And now if I divide by the minus 4 on both sides, the inequality has to switch. And it's not a minus 2, it's a plus 2. Right? Just keep in mind that the inequality switches if you divide by a negative. Otherwise it works just as equalities do. So what do we get? Minus 4 divided by minus 4, that gives me just an x on the left hand side. 2 divided by minus 4 is minus 1/2. So x less than or equal to minus 1/2. We can sketch it. We include minus 1/2, fill in the circle because it's a less than or equal. And we want all that side going out to the right, to the left. And we could also call this from minus infinity to minus 1/2. And since it's a less than or equals, we put in a square bracket. Okay, so that's how you can graph linear inequalities. And this is what the pictures mean, right? Any number here that's less than minus 1/2, if you plugged it in for x, you'd get a true statement. Any number out here that's bigger than minus 1/2, if you plugged it in for x here, you'd end up getting a false statement. So if you plug in, say, x equals 10, you get minus 40 plus 5, that's minus 35, which is not bigger than 7. So this is the true part, and that's the false part. And that's equalities and linear equalities, and that's essentially all there is in section 1.1. There are also some word problems in section 1.1, and that will be a separate video that I'll get to soon. And I'm having some issues with my power there.